Ladies and gentlemen, I'm Dasita Di Costa, and I will be your host for the evening. It is with great pleasure that we welcome you all to the 18th Stat Day organized by the Stat Circle of University of Colombo. This year, the Stat Circle of University of Colombo presents Stat Day 2021 under an impactful theme of surviving a pandemic, a statistical insight, with the objective of highlighting the importance of statistics during one of the most critical natural and social disasters of the 21st century. So moving on with today's proceedings, I would like to invite the President of the Stat Circle, Ms. Soumya Karunadika, to deliver the welcome address.
Thank you, Dasita. A very good evening to all of you. It is with tremendous pleasure that I welcome you all to the first session of Virtual Stat Day 2021. I must say, it is an honor to have each and every one of you here with us today. On behalf of the Stat Circle and the entire Department of Statistics, let me extend a warm welcome to our keynote speaker, Professor Amita Manatunga, Professor at Department of Biostatistics and Bioinformatics, Rollins School of Public Health of Emory University, Atlanta, USA. We are extremely grateful for taking time today. It is my pleasure to welcome the Dean of the Faculty of Science, Senior Professor D.U.J. Sonnadara, Head of the Department of Statistics, Professor Chandima Tilakaratne, the advisor of the Stat Circle, Dr. Sunetra Abesingha, Senior Treasurer of the Stat Circle, Dr. Rasika Jayatilaka, and all lecturers and instructors of the Department of Statistics and other departments of Faculty of Science. I would like to make this an opportunity to offer our sincere gratitude to all of you for the invaluable guidance and support given in making this event a reality. Next, I would like to welcome the guests representing London Stock Exchange Group, our platinum partner, Equity Knowledge Partners, our gold partner, Potenza, our silver partner, Creative Hub, and Slam Power Solutions, our mutual partners. We are grateful for your generosity and we are delighted to have you here with us today. Finally, I would like to welcome my fellow sisters and brothers of University of Colombo and all other participants with great pleasure. Adjusting to the new normal, we are excited to bring you Stat Day 2021 organized for the 18th time under the theme Surviving a Pandemic, a Statistical Insight. The COVID-19 situation has put an intense spotlight on the importance of the discipline of statistics. The necessary investment in statistics in turn would lead to guiding evidence-based decisions geared towards an improved quality of life for the people. In being with us here today, I believe all of you will be able to gain valuable insights into the field of statistics and the role it plays in this ongoing pandemic. Once again, I should say that we are very grateful for your presence and hope this will be a fruitful session to all of you. Thank you very much. Over to you, Dasita.
Thank you, Soumya. Next on the agenda is what we all have been waiting for, the keynote address of Stat Day 2021. If you have any questions to ask from the keynote speaker during her speech or after, you can direct them to me through the Zoom chat box, where I will ask those questions from her at the Q&A session. Today we have with us Professor Amita Manatunga. Professor Amita Manatunga is a professor in the Department of Biostatistics and Bioinformatics at the Rollins School of Public Health. Currently, she is the Senior Biostatistician for Georgia Clinical and Translational Science Institute at Emory University. In 2018, she received the Teaching Award from the Biostatistics Department of the Emory School of Medicine. In 2015, she received the Thomas Sellers Award from Rollins School of Public Health for mentorship, role model, and college collegiality. Professor Amita Manatunga also received the 2020 award for mentoring from the annual Emory Women of Excellence Award program, sponsored by the Emory Center for Women. She was elected a fellow of the American Statistical Association in 2004, a significant honor since a maximum of only 1/3 of 1% of American Statistical Association members can be elected in any the Elizabeth Scott Award in 2020. This award is for fostering opportunities for women in statistics and is given by COPSS, Committee of Presidents of Statistical Societies, representing 5 primarily North American professional societies for statisticians. Her being named as the Donna Jane Brogan Professor of Biostatistics at Rollins School of Public Health is a well-deserved honor of her past and ongoing career in biostatistics. Combining both methodological and collaborative research, she is the author or co-author of over 125 peer-reviewed manuscripts in well-regarded journals. Further, she has developed new and innovative statistical methods that address complex data structures for significant public health challenges, especially in mental health and nuclear medicine. So now, I would like to deliver the keynote address of Stat Day 2021. Professor Amita Manatunga, the screen is yours.
Thank you, Dasita. Let me share first. And can you see?
Yes, madam, we can see.
All right. Thank you. Thank you for the flattering introduction, and thank you, the Soumya and Ovini and other organizers of the Stat Circle. I'm honored and privileged to speak to you today at the University of Colombo. Thank you for coming and thank you for participating. As you see in this slide at the Rollins School of Public Health, that I work at the Department of Biostatistics at the Rollins School of Public Health. and at Emory University, located in Atlanta, Georgia, in the USA. So I know I have only half an hour. Who am I? I want to first say I was one of you. As you may know, I was born in Sri Lanka and have been in the USA during last 38 years, primarily working as a professor at Emory University. I first want to say I am very grateful for the excellent free education I received from Sri Lanka. I was the third member of a family of 6, and my father was passed away when my father was a laborer at the harbor at Colombo, and my mother was a weaving teacher. I grew up with very poor conditions with very limited resources. Thanks to the free education, I succeeded. I received my primary education from Dharmapala Vidyalaya at Panipitiya, and later I received outstanding education from the University of Colombo. I had a 3-year degree specializing pure mathematics, applied mathematics, and physics, and received a first class. Those days, after the first year, the students were asked to take an examination for selecting for the special degree. And just after the first year. And I took that exam and I was selected for the math special degree, but decided not to join because I was the only girl among 6 boys. So I pursued only the general degree, and I did not have access to people who could advise me at that time. Degree, late Professor V.A. Samarnayaka recruited me to the math department to do a statistics project in education, analyzing some data about education, which inspired my interest and started my career in statistics. I am very grateful for Professor V.A. Samarnayaka for introducing me statistics and giving me the opportunity to work in that field that I have been able to statistics from University of Colombo, and later I went to Indiana University and received the master's degree from Purdue University and joined the University of Rochester, New York, first receiving the MA degree and later receiving my PhD. So this slides illustrates my experience and what I am doing right now. And as you know, I'm a professor of biostatistics. I have 30 years of collaborating with biomedical scientists, epidemiologists, and mental health. Currently, I am running 2 clinical trials in addition to advising PhD students and teaching. And the first one is a clinical trial evaluating a drug in reducing a chemical exposure called the PBB among reproductive women. And in the second one is a cluster randomized study where we randomize the dialysis clinics to one into a standard treatment and the other one to the usual care. And the treatment is targeting patients to write their living will. And the third one is a more complex study, and we are collecting data from neuroimages, complex, high-dimensional data, and then the clinical information and symptoms. And the goal is to integrate all this complex information for improving diagnosis of mental health diseases. And the last one is currently developing a new image analysis algorithm based on pictures that were taken from the smartphone to monitor anemia among very low birth weight children in the hospital. In the past, I have worked in infectious disease epidemiology. I want to say currently I'm not heavily involved in working with the infectious disease epidemiologist. So let's first start saying that what is statistics. I know you all know this and most of you are in statistics. So statistics you have heard these two words, evidence-based practice and authority-based practice. And authority-based practice is quite familiar to all of us, right? Because while growing up, obviously, we had to listen to our parents. That was pretty much authority-based practice. And later, as professionals, we listen to politicians. The but evidence-based practice has to do with gathering data, analyzing data, and making interpretation based on the data collected. The essential skill required for the collection, analysis, and evaluation data is statistics. So statistics is the science of assembling and interpreting numerical data. It is the core science of evidence-based practice. So what do we do as statisticians? So we do method developments and then study its theoretical properties. We also analyze existing data using we analyze data using existing methods and make interpretations and conclusions. But I want to ask the question, as a profession, how can we make an impact in the world? And of course, one way to have a major impact is to develop new theory for new inferential problems. For example, we do t-test and regression, and all these inference is only applicable when the sample size is much larger than the number of variables. For the n less than p problem, inference is not well developed. So this is a very hard problem, and many people in statistics departments are working on this problem because this is much needed. And then the second thing is we can develop new methods and theory where conventional methods do not they apply for solving real world problems. And this is what I do. And this requires understanding of the background of other fields such as biology, infectious disease, epidemiology, and genetic, etc. This does not mean that you need to take courses in these areas. Given that you already have a strong background and given that you are a smart person, it is quite possible to catch up these fields as necessary. So, pandemic. The first question comes to mind is, where did it come from? And all these, nobody expected this. It's so surprising, right? So is it in fact a surprise? If you speak to virologists, it is not a surprise, because virologists, they study the pathogens and emerging pathogens. They do know that they are going to come time to time. They just don't know exactly when they come, but they do know they come to time. For example, Bill Gates and said 3 years ago the pandemic is nearby. So Bill Gates is quite knowledgeable about infectious disease epidemiology, So it's not that it is a completely surprise, but it for many of us it is a surprise. So pandemic started in December 2019, and it is called acute respiratory syndrome coronavirus, SARS-CoV-2. And so this was first identified as an outbreak in Wuhan city in China. So it was initially reported to WHO on December 31st. And the January 30, WHO, World Health Organization, declared COVID-19 as a global health emergency. And on March, after only 2 months later, WHO declared COVID-19 global pandemic. And the last pandemic we had was HL1 influenza. It was in 2019. But that pandemic only killed about 300,000 people in worldwide. And also most of the people were killed under age 65. COVID is a different case. COVID is very contagious, and up to now, it almost has killed 4 million people. So this is a joint statement done by the Institute of Labor Operations, and then the Food Operations and Institute of Food and Agriculture Operations, and the WHO on October 2020. This speaks to the effect of pandemic, meaning the economic and social disruption caused by the pandemic is devastating. And then they estimate that people are going to fall into extreme poverty, and in particular, the undernourished people, they estimate close to 690 million. And by the end of this year, it will increase by another 132. So the effect of the pandemic is, I think it is very personal to all of us. And as you could see, it is devastating. And this slide shows the relationship with the age and the effect of pandemic. And so the reference group is 18 to 29, almost undergraduates at University of Colombo. Okay, so that is the reference group. And compared to you, someone at 85 years age, their risk of hospitalization is 13 times higher. And their death is 630 times higher. So compared to you, very older person is at very high risk. For someone, one of your lecturers, or at the age around 50 to 64 years, you could see their hospitalization rate is like 4 times higher. And their death is 30 times higher if you have COVID. And for example, when Emory University was closed, or when it was near the pandemic, most of the lecturers and professors did not want to teach because they understood their risk is much, much higher than the students' risk. And compared to you, and very young people have a 4 times lower hospitalization and 9 times lower death. So the effect of pandemic is, as I said, is devastating, and it influenced so many health outcomes inadversely. And for example, higher mental health diseases. And this study was done at the United States. And so before the pandemic, the major depressive order and anxiety disorders, depression was only 11%. But after the pandemic, after this year, January 2021, the rate is 41%. So in the next few slides, I want to talk about little bit about disease epidemiology. And so here, it, you versus us. It means the research are targeted at the virus, and it is the virology and infectious disease epidemiology. In order to understand the study, understand the virus, we really need virologists and infectious disease epidemiologists. And they are working on how the virus spreads, and then they are working on the vaccines, and they are working on the new variants coming. So there are a lot more work to do in that arena, and they are also working on so many interventions. You meaning personally, if you got COVID, what is the treatment available to you? Meaning, do you need a ventilator? What kind of medicine you receive? So in medicine, one has to work in targeting a person, one person. Us means public health, mean populations. How do we reduce the spread of COVID-19? And how do we reduce the hospitalization and death? So that is, we need to target the interventions such as, the social distancing and mask wearing and so on. So I'm going to very quickly go through this slide. I know you all know about this. You can be infected after 7 to 10 days. You can start infecting others. And after 14 days, you may recover or have a hospitalization. And there are two important parts. important infection occurs many days before the symptom starts, and you are able to infect others before your symptom starts, you could see these two things makes it really hard to control the pandemic. And there are a lot of tricky terminology in infectious disease epidemiology, like pre-symptomatic, before symptoms start, asymptomatic, meaning without symptoms, meaning not everyone shows symptoms. So in the next few slides, I want to talk about how difficult to model infectious disease modeling. And so this is two group of people. And so these are healthy people in blue, and the red is the infected person. So there we have one person infected, and then this person get infected, but not the other person. And that person infect this person. So, and then you could see these two people become immune now. And then we have a visitor coming from another place, and this person has no access to this person. The reason is the infection path is broken now because these three people are immune. So some proportion of the population is susceptible to the infection. So this person cannot have access to this. So this is called building herd immunity, meaning if we can vaccinate a large proportion of people in the population, we can break of paths of transmission. In that case, we don't have to vaccinate everyone. A large proportion would be sufficient to break the paths of transmission. Why is it difficult to do modeling? And of course, we need statisticians to do that. One issue is this. You could see most of the regression and all these techniques we do, we write likelihoods. We write likelihood assuming independence. But here the outcomes are not independent because the people are related to each other. If I know the probability of someone getting the disease here, I know that it is going to influence the next person. So this assumption is violated. So, and then models are really useful of understanding the dynamic of the spreading the virus and the forecasting. And the development of such model requires substantial understanding of the infectious disease epidemiology and virology. And most models are based on stochastic processes, because of the violation of independent assumptions. And forecasting accuracy is also difficult to assess or verify. Let's suppose I develop a model and I'm going to say in the United States, in August, 200,000 people are going to die. Of course, as you know, here people are in thousands, 200,000 people are going to die. So when I say that my model is predicting 200,000, then people's behavior change. They take precautions, and the governments take precautions, and they have lockdowns. So what happens is when the August comes, so already the hospitalization and death are going to be reduced because of the social distance measures. So there is no way I can check whether I really did in fact was able to accurately predict based on my model. So this is one of the difficulty. And then there are also lots of issues with the statistical issues with the virus. This slide illustrates that point. So, for example, the red people are the diseased people with the COVID, and they carry a report card from the test, and this person says negative, but this person says, the report card says positive. And these are the people, normal people, not disease, but this person says it is positive. So in a test, we want to have high sensitivity and high specificity. What is high sensitivity? 80% high sensitivity means, given that you have the disease, what is the probability that the test says that you have the disease? 8 out of 10. Specificity means, given that you don't have the disease, that what is the test says? You don't have the disease, 9 out of 10. So in a test, we expect those with high sensitivity and specificity. But of course, personally, I care more about positive predicted probability, conditional probability, meaning given that I am positive, what is the likelihood in fact that I am positive, I have the disease? That is called positive predicted value. So interpreting conditional probabilities versus sensitivity specificity is important. I just put these slides, and I'm sure you are familiar with the dashboards of COVID-19, WHO, US Center for Disease Control and Prevention, Johns Hopkins University, New York Times. They keep track all COVID-19 there. Things to remember: numbers are people. Data are collected by people, data are entered by people. Most trained to be careful, but they are people. There is intense pressure on all aspects of the work. People want results. Sometimes politicians want results supporting their views. We are statisticians. We are not working for anyone. Our job is to interpret the data objectively. So this is one of the most exciting, at the same time exhausting times to be in the public health. I want to take few minutes to talk about a statistical problem. And why is it hard to count? Okay. So for example, the WHO made a statement, the number of COVID deaths could be 2 to 3 times greater than reported. Okay. So this problem illustrates why it is difficult to count. This number, I have highlighted 3 numbers here. I will go through with each number. And this number, 578,000 number, that was in fact, the COVID-related death reported to the Center Disease Control in the USA, meaning they had the birth certificates. When someone died, it goes to a registry and the death certificate says it is a COVID death. So this one is 577,000, but we all know there is a big problem in reporting. And then there is another estimate done by the CDC about COVID-19. It is called excess death associated. I will get to that. And that number is quite different than this number, 663, a little bit higher. And then the Institute of Health Metrics and Evaluation at University of Washington, they say COVID-19 killed 912,000. These numbers are quite different, as you see. So this shows the value of the statistics. Okay, so let me talk about the estimation of excess mortality due to COVID. Okay, so the question is, how many people died from any cause, if things were the same, if the pandemic did not happen, for example. So that is the question, excess mortality. If this thing did not happen, how many people died from any cause? Okay, so let's look at this picture. And y-axis is the number of deaths, x-axis is the year 2017 to 2021. These two pink arrows shows when the pandemic happened. Okay, so these areas is the death rate previously. So we can fit a model and we can see the seasonal effect of death, particularly in the United States, based on winters and summers. And this one is in 2018, I think the heat wave, you could see a little bit higher here. And here, these are the deaths due to pandemic, right? So I want to say this part between the arrow, the yellow curve, we are not observing. We only project that area. So these curves, if this pattern is true, we can project this pattern, assuming the same pattern. So then we calculate the excess death. And the excess death is 663,000. So this is how the excess death is calculated and excess mortality. If the things were the same pattern should follow. That's a strong assumption, remember. And then the excess death, we can calculate it. But of course, as statisticians, we know whatever we count has errors, so we model. We model observed count is true count plus error, and we use general Poisson regression modeling that account for seasonal effects and time effects. And of course, we cannot rely on only on a point estimation. We do confidence bands. So we project this part and then we compare to the actual numbers and we do modeling to receive the 663. So there is this alternative thinking. Alternative thinking asks a different question. The question is, what is the estimate of the total number of deaths that can be attributed to COVID-19? So this is looking at the problem in a different way. They argue to correctly estimate the excess mortality, one needs to take into account all the factors of change in mortality that have happened since the pandemic. So they say excess mortality is influenced by many factors. Okay, particularly it is factors related to the pandemic and the social distance mandates caused by the pandemic. Okay, for example, excess mortality can be due to COVID-19 infection that can increase when the COVID-19 infection death is increased, and then the healthcare being delayed. We did not have proper access to doctors, and then vulnerable people died during that time. So excess death can be increasing here, is increasing due to the healthcare delays. And then the other disorders, depression, that increases the excess death. And then also, and then there are certain other things. People did not drive, stay home. So they decrease the injuries, motor accidents. And so motor accident death was decreased. And then also other transmission of viruses. For example, influenza, flu, measles, that ultimately decrease the mortality. So their argument is this comparison of excess death, assuming this pattern is the same, is not that reasonable. There are factors that can change these curves, so we have to take another alternative approach. So they adjust the expected number of deaths using certain regression techniques to quantify the number of deaths, and they came up with the number 912,000. So this is a quite different approach. And this approach helps modeling the transmission dynamic of the disease and make better forecast and also understand the factors of the large and small epidemics across different countries. Because we already know different countries have different social distance measures. So it makes sense to account for some variability or due to those variables. So both methods are useful, but they speak to different quantities. And I know I have only few minutes. Looking ahead, I would say vaccine helps great deal. Okay, so efficacy and effectiveness varies depending on the vaccine. Some vaccines are quite effective, and the other issue is the long-term effects are known. But one thing I want to say is vaccine really works. Vaccine saved the United States, basically. So this slide illustrates the relationship, the importance of the vaccine. Y-axis is the death per million, and x-axis is the percentage vaccinated. And these points are the United States, the states. There are 50 states, but they highlight only few states here. And particularly these states are the South states. In the South, people are reluctant to get vaccine, although they are available to them. They don't believe in vaccine. They have religious beliefs and other political beliefs, so they don't take the vaccine. On the other hand, places like Massachusetts or Boston, high percentage of people are vaccinated. You can clearly see that is inversely related to the number of people vaccinated. So vaccination helps, and if it is available to you, please encourage people to take vaccine regardless of what the vaccine is. As I said, disruption of the pandemic is well known, and So looking ahead, we need to study these things. We have to document, and then we have to make conclusion and derive policies. For example, what is the effect on elementary education, so primary education of the pandemic? You know, we may want to have longer class times, longer school time, or maybe additional tutoring to keep up with the pace. And then the vaccine effect. This is also worrisome. Maybe people needs boosting. You know, there are so many lessons learned from the pandemic, and we need more global cooperation. When it was started in China, in the United States, people thought it was a problem for Chinese only. The President Trump at that time, Donald Trump, called it as source of Chinese virus. That was not very helpful because we need global cooperation. We need to share statistics. We need to share the information so that we can take preventive measures beforehand. So of course, for statisticians, more data are generated. And so it is useful to us. So I want to talk about one more thing. And so this was in the internet, Bluetooth to thermometers. And this New York Times had this article, can smart thermometers track the spread of the coronavirus? So basically, this company, they gave away smart thermometers to the people throughout the United States. And then they downloaded the temperature of those areas, of those people living in these areas. As you could see, there is a cluster of people in Florida with high temperature and cluster of people close to New York with high temperature and somewhere here. So we can identify clusters of appearing high temperatures, and we could use these data to predict the disease spreading. And so you could see, to do all these things, we need statisticians. And there are a lot of data from the iPhones and social media. There is a nice article about 2014, Google tried to model flu. Obviously, they didn't do very well because they were using the phone data and social media data. So it is an article about big data analysis. So big data doesn't necessarily mean lots of information. You can have good data in a small amount of data, but at the same time, you can have a big lot of data without much information that could lead to wrong conclusion. This is an important point when you collect data from phones, how to link clinical with other information, privacy information. None of us want to talk about what the disease we have or the doctors we go and all that private information. So we have to respect people's privacy and then collect data. And then we have to develop new method, possibly to analyze group data instead of the individual level data. So this is a summary. I gave you a little bit of an overview about the impact of pandemic that you are quite aware of, and the infectious disease modeling and testing, and the evaluation of vaccine. I didn't have much time. There is a major role in terms of evaluation the vaccine, particularly in clinical trials and early stopping. Because when the vaccine is developed, we don't know whether it works. We don't know whether it generates the adverse side effects. So at the same time, we know there are lots of people who need the vaccine. So it is a game between collecting data versus stopping trials for the efficacy. So that involves major statistical issues. So finally, I want to say future is very bright for statisticians, and science is an iterative process, which theories are developed, confirmed with data, and develop, refine into new theories, and subsequently refine into facts and knowledge. And as statisticians, we are uniquely positioned to have a major impact in well-being on the society. We are well trained in mathematics, in analytical training, and logical thinking. So we have a major role in terms of finding solutions to the complex disease problems. And I want to do a acknowledgement for one of my colleagues, Professor Lance Waller, borrowing some of his slides on the epidemiology, New York Times, and images from Google and some other websites. Thank you for the sponsor for the Stat Circle. And this is one of my favorite quotes, and get involved. And then basically this is by Dr. Martin Luther King Jr. and the late civil rights leader from Atlanta, where I live. Everybody can be great because anybody can serve. You don't have to have a college degree to serve. You don't have to make your subject and verb agree to serve. You only need a heart full of grace and soul generated by love. And thank you.
Thank you, madam, for enlightening us with that very informative speech. I'm sure the audience is now eagerly waiting for the Q&A session. We got some questions as well. So the first question is, from the data collected so far during the pandemic, will we be able to predict when the next pandemic will hit, and in what way it can be countered before reaching a global scale?
This is a very, very difficult question. And this is not something only statisticians can answer. This is definitely virologists know much more about this, you know. And as you see now, the Delta variant has come, you know. So nobody could predict the Delta variant, you know, even within COVID-19, you know. So the right now, Delta 89% of the cases in United States is Delta variant. You know, it is very dangerous and very contagious. So the it's really, really hard to predict, you know. But the ultimate choice is for people to have partnerships, you know, throughout the world and develop partnerships, and then the sharing the data and sharing the knowledge, and understand the importance of this major issue on humanity, you know, because still people pay a lot of politics, you know, like, I mean, this happened in the United States at the beginning, as I briefly mentioned, you know, in terms of, instead of controlling the pandemic and getting the information needed, they were more focusing on talking against China, you know. And at the same time, there was a lot of information coming out of China either, you know, to other world, you know. So it is really hard to predict exactly when these things occur, but at the same time, we have to have a good understanding. These things are going to come. The most important thing is how to make preventive measures, you know. And so then once it comes, then there are other issues that we all need to deal with, you know. But prediction is a very hard problem. I mean, we all know if we could do many prediction things, we can make so much money and we could do very well. Prediction is a hard problem.
Thank you very much, madam. And the next question is, today we all are experiencing a dilemma with regards to the COVID vaccines. There are many myths associated that are clearly not supported by statistics. Madam, to which extent can medical research and clinical trials provide evidence to assure that all vaccines are in fact safe? Any specific methods to test survival within a short period of time?
Yeah, first of all, I want to say vaccines are safe. Okay, vaccines are safe because I mean, millions of people, vaccines are given to millions people, and there are some adverse effects, but that proportion is very, very small, you know. I mean, it is almost like a striking, you know, some kind of, you know, accident or lightning or something, because the proportion of people who get adverse events is very, very small. Millions were given by the vaccine. So vaccine development itself is a huge industry. And in the United States and countries in England and Europe, and there are so many safety measures in terms of developing vaccines, you know. and the FDA, Food and Drug Associations in the United States, is responsible for releasing the vaccine. So any medication that we use day to day, you know, like a aspirin or anything like that, you know. So the number of people who are involved in these activities are humongous. We are talking about institutions. We are really not talking about even people, you know, because the measures for safety and efficacy is extremely taken well care of, you know. So and I don't know how much you know, when things are developed, there are 4 phases: phase 1 studies, phase 2 studies, phase 3 studies, and phase 4 studies, you know. So virologists first do the phase 1 studies, you know, with animals, phase 2 studies with the few number of people, and the phase 3 studies is more people, and then the phase 4 studies is they study more other aspects of the vaccine, you know. So they have a sequence of studies to do these things, and people should feel the vaccines are quite safe, you know. Of course, things can go wrong. There is no reason to think that everything will be perfect. There is no perfect world. One has to measure risk and the benefits. If we don't give the vaccine, many more people are going to die. You know, are we going to save more people giving the vaccine that may have a very slight adverse effects, or are we going to decide not give at all? You know, so the better thing to do is to minimize the death. You know.
Thank you very much, madam. And the next question is a general question. How did you become interested in this subject, and why did you want to teach it?
How did I? So I want to say I started my career, as I said, under Professor V. Samarnaik and Savitri Abhisekara, and and then I actually analyzed data in Sri Lanka, London, sorry, not London, advanced A-level results versus how they perform at the university. So I was looking at regression, correlation between those 2 outcomes actually, under the guidance of Professor V. Samarnaik, you know. So as you see, that was a quite confidential work, you know, because I had access to lots of personal information, you know. So the it really inspired me looking at those relationships and trying studying is that. So that was the beginning of it. And then actually I went to statistics department, and then I did have a PhD in statistics, not biostatistics, you know, PhD in statistics. And then when I started working, I had access to the School of Medicine and working with physicians, you know, and then some epidemiologists, you know, working in other health related matters. So I was quite intrigued by those health problems, you know. So that's how I think I am very lucky. I can say honestly, I am very lucky to have a job that I really like to do, you know, because I get to hear different stories every day from different people and why it is important, you know. People come to me and talk about their studies and tell me why it is important to study those things and what kind of impact it has if we can find the answers, you know. So I would say I was really intrigued by the data and the structures of the data and complexities of the data, and then trying to address different questions. So that's how I kind of became a biostatistician. But in order to do all these things, and we really have to we really need to kind of learn the background. So you should have some commitment for that, you know, because you cannot really listen to a story and can kind of get satisfactory answers to them, you know. So I can take only a few minutes. I think I can take, you can see my screen. Can you see my screen or not? No.
Not currently, madam.
No? Can I take the screen very quickly or no?
Yes, I think you will be able to share.
Okay, so this is a study actually that I am currently working on, and so I'll take only 2 minutes to talk about it. These infants are very low birth weight infants, like they are very small. You could almost like you could hold by a hand, one hand, very small. So we monitor that, and they have very low birth weight. So we monitor them over time. They stay in the hospital about 50 days and they develop anemia due to low birth weight, meaning we have to give blood transfusion. So you could see these arrows means at that time we have to give blood because they have anemia. But the issue is if you draw blood, it is counterproductive because the reason is the more you draw blood, they become more anemic. So we are trying right now, we are trying to develop algorithm instead of drawing blood, whether we can predict those values. For how do we predict? We take a picture of the fingernail. So fingernail of the infants, we take a picture. Every picture comes with RBG, red, blue, and green. And these are matrices of data. So we use this data to predict the CBC levels. So someone has already developed an algorithm for older people, not for these tiny infants. And this left-hand side one shows that how well it predicts. You could see because this was done for adults, it miserably fails, because the line corresponds to the how well we predict. So we did some new methods, principal component analysis methods, and then we are still trying to develop those methods. And you could see this is only with 25 infants, we are doing pretty well, So this is the kind of the work I do. So in this case, the idea is rather than taking a blood draw, we can take a picture, and then the next time we may want to take a blood draw, and then we can take a picture again, So that would minimize the blood draws, of these infants, monitoring anemia. Yeah, please go ahead.
Yes, thank you very much, madam, for that very detailed explanation. Uh, and the next question is, by comparing to the data of previous natural and artificial diseases, can you say whether COVID-19 is a natural or man-made virus?
No, again, virologists can say those things much better than us as statisticians. And no, those are very hard questions. There is no way. I mean, the studying about pathogens is not an easy task. There is no way say how COVID-19, and the thing is it is believed that the COVID-19 was transferred from animals to humans. From animals to human. That is, there is some evidence for supporting that, it came from bats and it is transferred to human, So, so they can talk about, they have some understanding how those diseases come, but at the same time, not they don't fully understand even today,
Thank you very much. And the next question is, I am interested in biostatistics. What special advice would you give a person entering this field? And what are the career options in biostatistics?
Okay, when I finished, I said statisticians, we have a very bright future. In the United States now, the statisticians is the most popular, I think the first or second most popular, highly paid profession. Why? The reason is most of the companies and most of the institutions, they use data-driven approach to they make decisions, For example, Google collect all the information. Every time you do a search, Google collects your information, what type of the things you search, If you say hair dyeing, okay, it's more likely to, when you search the next time, you get an ad saying that this hair dye is available to you, So how do all these things happen? All these things happen because they collect your data, and based on your past data, they can tell you what are the things you are more likely to buy. So companies are selling products, At the same time, the lots of decision-making process, even political campaigning, political campaigning, people use data. People figure out what people like, and then they try to deliver Facebook messages based on that. So all these things require statisticians. So so the excuse me, I'm wondering whether I lost you. Did I lose you?
No.
Okay.
You're there.
Um, do you hear me?
Yes, we can see you and hear you.
Yeah. Okay. Good. So the other misconception about biostatistics is, I really want to emphasize, is people think biostatistics is all about data analysis. It's not all about data analysis. No, that's not true. Biostatisticians develop methods and study theoretical properties of those methods based on the real world problems. So that's what biostatisticians do, as opposed to a mathematicians or a mathematical statistician. So they really get exposed to the real world problems. It can be medicine, it can be economics, it can be environmental health statistics, or it can be global health, or it can be even health policy. So, and then that's what biostatisticians do. Biostatisticians are well aware of all the statistical techniques and the theory associated with those techniques, and then they develop new theories that is more targeted, more suitable for the specific problems. So that's what biostatisticians do. So if you are interested in doing biostatistics, first of all, you have to have a strong mathematical background. So as you see, I had a general degree, 3-year degree. And when I came to the United States, I struggled quite a lot because I didn't have a very strong mathematics background. So I actually had to pick up many things by myself, because I didn't have a strong background in mathematics. So it is important that you have a good background in mathematics. Then the other things like biology and all the other things you can pick up on the way. So that's what most of the biostatisticians do. They have a background in mathematics, and then they study statistics or biostatistics, and all the other things they pick up on the way. And please, if you need clarification, please ask. Yeah.
Thank you very much, madam. And since we are running out of time, we'll be ending the Q&A session now. And I hope the participants will get all their questions clarified as well. Thank you very much, madam, for gracing this occasion and for sharing your invaluable thoughts and insightful knowledge with us. It was a great pleasure and a privilege to have you with us this evening. Thank you very much.
Yeah. Again, thank you very much. And I will email my slides to Ovini, and it will be available to you. And then again, this is an honor, and thank you so much for having me.
Thank you again, madam.
Yeah.
Ladies and gentlemen, so now it is the time to mark the end of the first session of Stat Day 2021, the keynote speech. We hope you enjoyed participating in today's event as much as we did presenting it to you. Hope you take back pleasant memories of today, and thank you so much for joining with us. The second session of Stat Day 2021, the guest speech will be conducted by Dr. Vishwadanture Bandara, will be held on the 6th of August from 5:30 to 6:30 p.m. We hope you will all join with us on that day as well. Before we finish, I would like to invite you all to pose for a virtual photo. For that, please turn on your camera for a minute, if possible.
So can I leave now?
Okay, so thank you very much. So now it's time to wind up the today's session. So good night and stay safe.